Okay, hello everybody. I'm Richard Southwell and I'm very interested in shapes. And recently, there's been some amazing discoveries about how one can create fascinating shapes such as this one, and this one, and this one, and this one, and this one. How one can create these amazing objects very, very easily. One can design them within seconds, and with 3D printing, of course, we can create them very, very easily. So I mean, look at this object here. It's you wouldn't say it's completely random. I mean, it certainly has some kind of structure to it, some kind of symmetries, and it's visually pleasing. So it's not terribly complicated, but on the other hand, it isn't terribly simple either, and it's quite hard to imagine that a human could be creative enough to come up with a design like this, I think. Okay, so essentially what I want to do today is to show you how you can easily create things like this, and how you can explore the amazing world of network growth. And I'll even show you how to 3D print these objects on your own, and you will be amazed how easy it is. Because I've put a free piece of software on the internet, and essentially this just allows you to just search through this massive space of different network growth systems. It's really very much like fishing. You just look at the consequences of random systems, and then when you find one you like, you just pick it out and use it. Just like fishing, if you find a good fish, you take it out and you use it. So this is the basic idea. So I think one of the most amazing things about these type of systems is that they're all generated by very, very simple rules. Really simple, small rules, completely deterministic, so there's no randomness involved. And so you can make a structure like this. Well, this is fairly regular, right? It's easy to understand how this could be generated by a simple kind of rule. But a very similar rule can generate a structure like this, or even a structure like this. So essentially, what we find is that when we just explore the dynamics of these very simple rules, we find out loads of absolutely amazing things happening.
This is the program that you should be using. It's called Network Explorer. In order to get it working, you'll have to download this program first. It's called Wolfram CDF Reader. So if you just click on this button, it will take you to the website, and you can just download the CDF Reader for free from there. And once you've done that, it's very simple. You just have to click on this button here and my program will load up. The system's really very easy to use. Every time you turn it on, it generates 5,000 random rules from the massive set of systems, and then you can explore them very easily. So we can have a look at 3D pictures of them. We can make these pictures larger, and we can just go through the different rules one at a time and take a look at the different kinds of behavior which are generated. For example, this generates a kind of loopy structure. This is kind of interesting. It looks cylindrical. Yes, it seems to have some kind of cylindrical form. I don't think I've seen anything like this before. And so here we seem to have found something very interesting, because I imagine this shape could actually have some practical uses. It could make some kind of very nice bangle, or perhaps even it could make some kind of bowl if one filled in these different faces. So let's make a proper, better kind of 3D picture of it. So the code is 223143.7. Let's record that here. And so here we are. We have this nice looking 3D rendering. So this is now made out of cylinders. I think if we make these cylinders a little bit wider, it will make the shape look better. And so perhaps you might find something like this, maybe not exactly the shape, but let's face it, I'm giving you a fast example of something which I found within seconds. If you spend a long time on here, you'll easily be able to find much more beautiful pieces of art and so forth, which you shall be able to use. But if you wanted a 3D printout of this particular shape, it's really very easy. And so all you have to do, if you want to get a copy of something like this, is just to take this information here, copy this, and send it to this email address. And you will receive some information about how you can get this shape 3D printed at different sizes, and so on and so forth. So let's have a look at some more of these systems. We'll go into 2D mode. So you can see this one here. This has a kind of fractal form. It will become more clear if we increase the level. So essentially, you can classify these rules into whether the behavior is regular, or fractal, or complex. And that's a good way to classify the different behaviors. Now, another thing you can do, which is quite interesting, is if you find an interesting rule, you can go down here and create a nice three-dimensional rendering of it, just using these options here. And if you want to do this, and then send me the details of the rule, I can actually get a 3D print of this rule and send it to you. So it's well worth exploring these things, because some of these objects are useful for particular goals, and some of them are good for actually creating real objects like pieces of art. And so during our investigations we will almost certainly come across systems like this. As we search through these different rules just by changing the rule number, we'll see many different sorts of systems, and quite a few of them will have this kind of elongated shape. And so we can continue our exploration. We can explore the different behaviors of these rules. So if we change the rule number, we see these different networks, and ooh, this one looks very interesting. There's certainly something interesting going on here. This structure is very different to the usual. It looks much denser, and with many kind of parts which seem to be passing through itself. So this is only after 100 time steps. Let's take a look after 200 time steps. Ah yes, and we can see that this is a fairly interesting kind of network. It seems to have several different pieces doing different things. I dare say that this one has a particularly complex shape. Let's run it a bit longer. Ah yes, so there we see. This network is growing in a very complicated way. There doesn't seem to be any regularity. Although, well, there do seem to be these self-similar structures, but it's not fractal on a kind of global level. So it has a few of these large kind of holes, and some of these structures look similar to others. So, for example, the thing over here looks kind of similar to the thing over here, but I don't think they're exactly the same. So perhaps the way that this network is growing is kind of mirroring the way that sort of cities around the Earth would pop up. And cities are similar to one another, but not exactly the same. And so we can continue our search. Some of the systems don't do anything very interesting at all. For example, this one doesn't even cause the initial cube to grow very much at all. But if we carry on, we find other things. For example, this seems to be creating some kind of large ring structure, and if we run it for a lot more time steps, we see that actually that's not the case. Something more interesting is happening here. This is quite a surprise. So I'm not really sure what's going on in this case. Let's try and run it for 500 time steps. Ah, this is very interesting, isn't it? There's many different kinds of self-similar twisty bits, but they seem to be appearing in a very kind of unpredictable way. Let's see if we can run it for even longer. There's a problem with this computer, which is that sometimes if you try and run with this program, because sometimes if you try and run this program for too long, it can crash and one has to restart it. Okay, so this looks like a very, very interesting form. And so now we've found this interesting structure, it's a good idea to classify it and add it to our database. Because essentially we want to build a database to record all of these different things that were found, sort of as a community. And then we can start to gain some understanding about what kinds of things can be done with these systems and what kinds of dynamics these systems have. So in order to do it, it's really very easy. We'll just take a picture of this. So that can be done by pressing print screen and opening up panes and then pasting, Control V for example, and we can just grab this picture here and we can save it as something. And then it's really very easy. You can just go to this website here and record findings, and then all you have to do is fill in the name, and you can put a description of the network. So it seems to be a kind of regular structure, sort of cylindrical, and it sort of looks like a bangle. So that's a kind of potential application of this particular system, and now we can upload it. So sometimes it takes a while for these findings that one has got to actually be displayed, but if you click on the View Findings window, you can actually see a collection of previously found networks, for example this one. And so eventually the aim of this is to create a very large database of different kinds of networks with different kinds of applications.